hear me. And then for posterity, I want to cover a little bit of what I've done on this piece of code. And let's get TV capture going. Yes, test 1, 2, 3. Test 1, 2, 3. Okay, sorry for the squeaking, but now I know you all can hear me, and it's recording. I'm turning on my screen here for a second, and yeah, I'll just jump into what I'm doing today. So recently, I've been wanting to, I've been working on composing music, and I've been kind of struggling with the actual composition process of wanting to do through composing versus doing loop-based kind of composition. And so I thought maybe one of the best solutions would be to analyze some songs I like that sound complicated, even though I kind of know they're not. But also to examine like the variation that happens upon like a loop, even something that's only repeated 4 times, that has certain different fills, and that is in like an A, B, A, C general kind of form. So the idea that I got was, well, why not build a program in processing that would basically where you could load in a wave file or a couple wave files, and then lay them over each other in order to see what the difference is, right? See what the difference. So you have this part that repeats, like any, again, like the kind of arbitrary examples, like you have like a section of a song. It kind of repeats 4 times, but it changes a little bit. And that's what I'm interested in, is like, okay, I want to see what changes happen, right? And so what I've done in order to try to visualize that is made a processing program. Well, I should say I'm in the process of making this processing program that will load in a wave file and then draw it around a circle and then loop over itself, and then hopefully is set up in the correct sort of way that if there's variation in the loop, then we'll be able to see it. We'll be able to visually inspect it. So again, I just want to run through, it's not a lot of code, the code that I've written so far, in order to kind of look at what's necessary to, so far, all I've really been able to do is like load a wave file into processing, visualize it, you can kind of see here, and then I was experimenting with getting this white line to be a playhead. We'll disable that, and I'll run the code again just so you can kind of see what's going on here. But yeah, so let's go and find this function. Okay, draw playhead, I've already taken that out. And then I will change this one function here to 1. You'll see why in a minute. Yeah, and so then we'll have a go. And hopefully, again, I'm going to play this. I think you guys are hearing this. Okay, so again, all this code really right now is doing is loading in a wave file and then saying, okay, I want to draw a circle, and then I want to display the wave mapped around that circle. And so the way you do it is, and I might as well go through and comment my code for best practice while we're doing this. Sorry, I have to adjust my stand again. I should really get a better mic set up. Okay, so first thing to do is you have all your initial declarations up here, where you can set up the various objects I don't even know actually if I use this audio sample object again, so might as well clear that out. Yeah, we don't. Okay. So the first thing is the audio sample object up here. I believe you need that processing library. And then we've got our variables for the height and width of our window. Okay. And then we have this array, and we have this array that holds sample data. And you'll see here, processing will allow you to load in a WAV file, and then it will ask you, or I'm sorry, you'll have to give it a special command in order to get the raw data of that WAV file into an array, right? Then we have a variable for drawing circles, theta. Theta for, we'll say polar, well, this would be Cartesian to polar. Okay. So that's all of our kind of global variables. We do our settings here. One thing, this is a little nugget of magic. It took me a long time to realize about, or to learn about processing, is that if you want to have the window size be variable, you need to use this function called void settings. Yeah, I always wondered that, why if you put size in background void setup, it doesn't work, and you have to give it static numbers. But here you can actually define it with variables. So that's kind of the whole point of that, right? Okay, so then we get into our setup, and we say, okay, background 0 draws a black background, right? Okay, let's get this. Draws a black background for our window. I have a bunch of sample code copied from like the processing documentation here. Okay, and then still going down. So where we say file equals new sound file, this loop.wave. So this is where we actually take our sound file object and we say it's equal to a new sound file of this, and I have a loop.wave is located in the folder for this Circle Wave Viewer project. You need to have that there, and you can change this. You can put several waves in the project folder and then just change the name, load different ones in. Let's see, should be kick.wave. We'll give it another one. Okay, so now you see an actual kick looped on itself here. Okay, so anyways, we'll redo that because we're interested more in what the loop has to offer at the current time. Okay, so here's a couple of little utilities for seeing information about the sample that we just loaded in. We can see how many total frames of audio there are in there, and we can see the sample rate. You don't really have to worry about the sample rate, or at least I haven't done anything where it should kind of work, whether it's 48 or 44.1 K, doesn't matter. Okay, so we print out those variables, and then we load our our array full of the data from the audio file that we load in. And that's where we use this sample content. So this is where we're going to say load wave file data into readable array. Okay. And actually, this 2 lines, this is the second line is actually doing this action. First is we initialize array to size of audio file in frames. Okay. So to be honest, I've just been kind of doing the quick and dirty, and there is, I think because it's stereo is why we say that we have 2 times the number of frames, right? Because each frame would have 2 samples associated with it. I don't know if those are like one after another, and to be honest, I think I'm just drawing them all twice because I'm being lazy and didn't want to be perfect about it. But it works. It probably would save us some computational time, and I should probably look into that. But we're not going to worry about that right now because I'm being impulsive and having fun. Okay. So this is all, again, we're still within the setup. So this is the setup function. It only runs once. And then we have this function called draw circular. So let's go down to there and look at what we've got inside of draw circular. So first of all, we set the color mode. I'm not even going to label that. I mean, that's just so readable. Okay. And then this is where we actually draw the circle that you're seeing here. Now, one thing I'm kind of curious, maybe we should do, and just to see kind of how, so you can get an idea how when I was writing this, I kind of started my process. Even though, okay, that didn't work. I started off by doing this function called draw straight. And draw straight, the point was, I wanted to make sure I had the logic for loading in all the things, all the data correctly into our the data from our audio file, I should say. And let's see if I can get lucky here and say stroke 00 255. So again, we're in HSB mode, meaning that we don't care about our hue. Our saturation, we want unsaturated, we want white, and then our brilliance is going to be 255. Because we want it to be bright all the way. So let's see if we can get that to work. And do something nice. Okay, cool. Yes, that worked. So now we're seeing the waveform. It was just being drawn in black before because I stopped using this function. But yeah, let's go through the draw straight function. So the draw straight function says for, so we've got a for loop. I is less than file.frames times 2. So for each value in, what is this one called? Sample content. Now, we could have written this a different way and said that we wanted to do this not necessarily by this file frames times 2, but by the actual length of sample content. I forget off the top of my head what the operation is. I think it maybe is just dot length. But we define the length of sample content with this same expression. So this for loop is going to scan through all the audio data we have, right? You can see it's pretty simple here. We have our color mode set. We do our stroke, which is the color, or rather it's usually the outline of the color, but we're doing a dot, so I think that's what colors it. So then we've got two variables, gain equals 100, and stretch factor. And basically, this audio, we don't know, or we're getting in a number of how long the audio sample is when we load it in, right? We like some arbitrary number. So we have to stretch that so that, we wanted the beginning of our sample to start here and the end of our sample there. So we have a little bit of math, and I'm actually seeing this now. It says 640. It should be draw with, which equals 640. So we're going to go down and swap that in. And yeah, so we have file.frames over draw with times 2. And so that makes sure that whatever wave file we're drawing, its start and its end will just fill in this window we have here, right? Okay. So, and then we have the last bit of our for loop here, which is we draw a point. And, for drawing points, we put in the x coordinate and the y coordinate. The x coordinate is I divided by the stretch factor. And then the y coordinate equals this math right here. And so basically, as you go through this for loop, it draws a dot all the way around, right? And then we use this draw height over 2 to make sure that it's centered with the y coordinate. Because remember, positive y values are going to move you down, and positive x values are going to move you over to the right. And so as we're moving to the right with the I, which increases with our for loop, we want to move up and down based off the audio content, right? So this draw height makes sure that we draw exactly, we're starting in the exact middle, and then we do plus sample content times gain. So the sample content is our actual audio data, and then gain multiplies it to make the peaks or the valleys bigger here, right? And so maybe for just a little fun example, we'll set that to 300, and you can see it'll make the actual wave drawn bigger, right? Okay, so let's set it back to 100. I like that factor. So again, if you're not familiar with working with audio data, we're at 4.1 kilohertz, right? So 44,100 samples per second. And then each one of those samples is going to be a value from 1 to -1, right? Which is the amplitude values that we're going to see. So that's why we need the gain, because if we didn't multiply it by a certain gain factor, it would be moving up and down by less than 1 pixel in here, and we just wouldn't see it. It would look like a flat line. So we have to amplify it, right? Okay, so that's our draw straight function. And again, I'm showing you just to take you a little bit into my problem solving approach when I was first prototyping the code I have so far. I wanted to do this before I tried to map it onto a circle, just to not take on too many things at once, right? So we're gonna go ahead and comment that out, and then we're gonna comment in draw circular, and then we're gonna hit run, and then we'll see a slightly different picture. So let's go down to draw circular and check out that function. So again, we have a color mode. We're setting it here. We have this for loop that for all data points in, we're just going to say sound file because I forget the name of that array and I'm lazy. This is the same for loop that we saw in draw straight, right? Except we've got a little bit more math here. So first of all, we see this wrap value, and let's skip that for a second. It's 1. Let's just ignore it. We'll play with it in a minute like we did already. Okay, gain, we know that. Stretch factor. You'll notice stretch factor has changed because now we're drawing the audio in this circle as we're seeing it. So it's the same thing, except we're mapping it to a radius, and we're modulating that radius with the audio data instead of going up and down from that line that moves halfway across our drawn screen here. So this is where pi comes in. Again, we want the sample to be drawn one time over the entire circle. So, and actually it's starting right here and draws this direction and goes back to the front. That's just a little bit about polar to Cartesian conversions. We'll talk about that in a minute. But yeah, that's where this 2 pi comes in. File frames over 2 pi times 2 to make sure that the length of the audio file is equal to, or is rather stretched to fit on one full circle draw, right? Because if you're drawing a circle, you're going from 0 to 2 pi in terms of radians, and then we want that 0 to 2 pi to be mapped to the length of our sample we're looking at. Okay, so next two variables we have center x, center y. These are simple. Again, you see draw width and draw height over 2. That's just letting us have a little neater way of saying that we want the center of our circle to be here, and that should be halfway across and halfway down. Okay, so now we have radius, and the radius is actually where we're integrating the audio data here, and you can see that we have a base radius of 180. So if we had no audio data, you can see where the circle would be, and then plus, again, we have gain multiplying the sample content. So the sample content is going to modulate that radius and actually draw our audio. Okay, so now we have our theta. Again, if we're drawing a circle and we want to draw a circle once, we're going to draw it from 0 to 2 pi, because 2 pi is one full rotation or one full trip around the circle in radians. And then here we have our stretch factor times this wrap variable. And again, wrap is once, we can kind of ignore it, but this is where we're calculating our degrees in radians as we're drawing. And you'll see why that becomes important in a second. We're going to skip 8-bit theta. Well, actually, I'll just explain 8-bit theta real quick. So this is the same as something like a stretch factor, except that what we want is, instead of, we want a variable that's going to go from 0 to 255 right at the end here. And if a number is 8-bit, it goes from 0 to 256, or 255 rather. It's 256 discrete values. And I like to work in 0 to 255 when dealing with my colors. And that's because, a lot of the LED work I do, that's also 8-bit data. You're working with 8-bit colors. And so, this 0 to 255 paradigm, 128 is about halfway, etc. I like to keep consistent with that. So I've set up this variable to give me a value that goes from 0 to 255 as we're essentially drawing this circle. And this is what ends up coloring this from red through the rainbow back to red using that HSV coloring convention. You'll see that line of code down here, right? So just think about that. The 8-bit theta, as that goes from 0 to 255, that's what changes the actual hue here and takes us through the rainbow. Okay. And then, so let's keep going down. Now we have float point X and point Y. These are, I'm noticing a little mistake, but these are basic Cartesian to polar coordinate equations, right? And again, I might have a sign mixed up on this. Maybe that's why it's going that way instead of this. I don't really care. I just know I start here. The only difference is it would flip the circle or start us at a different point. Yeah, and so here we have our, we're calculating these points that take us and take this, these, how do I say it? We're converting from a radius and a theta value into an x and a y value. Simple polar Cartesian conversion here. And so these are our actual x and y points, because there might be a way, I haven't looked into it, to draw the points with polar coordinates, but I don't really want to think like that necessarily, or I guess I just didn't look into it. This works, right? So that's our whole for loop for the draw circular. Again, we kind of go through, we figure out what the radius should be based off the audio data. We know that the theta just increases with our I at a given factor, and then we kind of divide that up by the number of frames, and then we draw a point, and we set the color of that point to go all the way through the rainbow by our 8-bit theta value. So that's all the steps really required to draw this circle, right? That's how we map this onto there. Now I want to go back to the wrap variable here, okay? And this was when I added in after the fact, because this is kind of playing back into the original idea. So if I play this again, we have this one line of code, file.play down here, that will play the sample in its entirety. So I want you to listen, and we're going to listen through it once, and it'll go along here. And you'll notice it's not going to, you'll have to kind of imagine and follow it. If it helps, you can look and see these big shapes here are the kick drums that come in. So we can actually see that this is about 8 beats long. We can't really see exactly, all the detail we want right now, but you can kind of follow the kick drum, dum, 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 as we go through. And then we'll touch back on why that wrap variable is and what it does, right, when we change it. Okay, so when I change wrap to 4, what it's going to do is, instead of mapping the beginning of, we have this one sample, and it goes all the way through the sample, and by the time we draw a complete circle, it says, okay, we've drawn the whole thing, we're done. Wrap, by multiplying this theta, is going to say, we want to draw 4 circles through the entirety of this loop, right? And this plays back into the main idea of why I built this program, because I wanted to take a section that kind of repeats in a song, and I wanted to lay it over itself in order to see what changes between those, because I'm trying to make my music more interesting, and I'm trying to take some of my favorite artists and say, how do they have a loop but keep enough going on in it so that it stays interesting? Because there's this kind of like I think we're finding this balance between wanting to repeat things that sound good, but wanting to have them evolve as well. So, okay, I changed the wrap variable to 4, and then we're going to hit run, and you're going to see that now, because we've changed it to 4, this section, all the way down, if you follow the mouse, to just a quarter around the circle now, is going to be one whole circular, is going to go around. And so this is actually going to redraw it on itself. Now, one thing I do need to note at this point is I'm starting to get to the point where my work on this program leaves off. And once I kind of get right up to where I got in terms of the completeness of my work, I'm going to stop talking, thank God, and put some music on and start working on the program again. So we're kind of getting up to that point. So you're going to see it will just draw over itself. What I'd like to do is add some transparency to it, so that way you can see more clearly what's repeating and what's not. So all right, we're just going to run the program again. Once again, wrap 4. So you're going to see a circle, and it actually the entirety of our 8-bar beat is going to be wrapped around that circle 4 times. You'll kind of see it. Okay. Now it's nice too. You can see we're getting a lot more detail about what's going on in the beat here. Lots of you can already see a lot that's very interesting. Kind of inspires me to add more features, but yeah, primarily is that you see kick and then some kind of hi-hat stuff. I don't want to say shaker, it sounds like some other perk. But yeah, I'm noticing interesting things. If it was exactly on the 16th notes, we'd notice that it's divided cleanly at the 8th. It's not. There's a little bit of swing to our beat. And you can see these big waveforms kind of showing up in our, because these are our kick drums, they got a lot of bass. And then you can start to see some of this green in the background here. So, again, what I would like to do, and I'm going to try to do here soon, is take it so that instead of just drawing itself in red, opaquely, which it should be going through the colors too, it'll be transparent, the colors will combine, and then we'll be able to start really seeing the differences between what happens in the 4 times this loop goes through. So there might be other problems. Our 8-bit theta might not be really doing us justice here, and we might need to incorporate the wrap into that. This is going to be some trial and error. Okay. So the last thing I want to show you before we go and I go into work mode is this draw playhead function that I got kind of working, but still needs a little bit more tuning. So in the draw playhead function, I found out there is another function based off of this. It's a method of your sample object called .percent that will return the percentage of the way through the sample that is being played. So what I want to do is I'd like to have the whole thing playing such that we have this white playhead that shows you where it is in the sample, so you're not having to just do it by ear. Now the issue that I'm having right now is that it takes a minute to draw all these samples. As we notice when we compile the code, it doesn't happen instantly, and then we draw over it with the white bar, but the white bar inside of this draw playhead function, which really I don't want to go through in detail, is based off of our draw circle function, but instead of taking the audio into account, it draws a line that goes from a smaller radius to a larger radius. But yeah, so again, this is kind of where I got to in my development, is that it draws the line, but it will start, it won't erase the last line that was drawn, which is a problem. And then I need to find kind of a smooth way to save this image as it's drawn the first time, because we don't need to redraw it, and then load it back every time we call a frame without actually doing all the calculations. Like save it as a 640 by 640 picture, and then load it back in instead of going through our for loop and calculating all these radii and placing these dots, right? just as the play loop. I'm sorry, the playhead moves around. So let's run it one time with the playhead, and you'll see exactly what I'm saying. And this is where you can pretend like you didn't hear what I said and criticize my code, right? So we see this playhead moving around it, and as we do it one more time, let's just let it keep going. Okay, so you see the playhead roughly corresponds to the part in the sample that we have shown here. All right, so now that I've brought you up to date on the code, again, I'm going to stop talking here and go into work mode, which is going to be, opening up the API, documentation, trying some things, debugging a little bit of this, a little bit of that. Yeah, so maybe depending on what I get done this time, I can go over those changes the next time. But for now, I'm going to kind of stick my head on it and just put on some background music. So, yeah, thanks for tuning in. And, yeah, enjoy.
Before you scroll away, you need to hear this. Republicans across the country are moving fast to enact massive voter suppression laws.
All right, y'all. That's all the time for today, and I want to try this with some copyrighted